Hey, it's Rake. I just want to introduce you to a new member of the Guided Hacking family. His name is Cody. He's going to be doing a series on YouTube for Counter-Strike Go and maybe some other things. I want to say a couple things about the videos. Number one, the first couple videos are in 720p, so I apologize about that. But the rest of the videos henceforth will be in 1080p. Now, he doesn't show a lot of the reversing stuff. We've kind of already showed that in our previous videos. So he's going to focus more on coding. And so if you need to update offsets, you can watch some of our older videos, specifically the how to find net far offsets video. And you can always use Haze Dumper as well. One other thing Cody does is he uses DWORD, which is a 4-byte integer, for all of his addresses. Now, it works fine for CSGO because it's a 32-bit app, but you will have trouble using his code in 64-bit applications. So you want to use something like uint pointer underscore t, which is what we use in our other videos. Another thing he likes to use is Multi Byte Character Set, which is for like the string literals. And like in my videos, I always use Unicode. I do that because it's the industry standard and because it's a default setting for Visual Studio. Now, really, you can use whatever you want. He's got some high quality code and content, and I really hope you enjoy those videos. Please give him a warm welcome, and I'm going to let him take it from here. Thanks.
Alright, in this tutorial we're going to be doing pretty much just a very simple and basic CSGO Bunnyhop. It's going to try to be explained out very well and should be something that anybody can really follow on with. So, I guess we can go ahead and get started. First things first, you're going to want to go open up Visual Studio, go to New, Project, just normal Windows console application, and give it a name of whatever you want. Alright, so we have it named as bhop tutorial. Let's go ahead and go to it here. Now in the description you will have a .rar file that contains my memory class. Granted, the get process and get module are not written by me, but you should have two files, the memman header and the memman.cpp. So you want to go to your project folder, go to the name, and click and drag both these files in here. Alright, go back into Visual Studio, go under header files, right click, add existing item, add memman.h, then go to source files and do the same thing but for memman.cpp. Alright, now we can go ahead and get rid of stdafx, delete that from the source code, and delete it from the header file and the CPP file. Then go to Project, Properties. That is not set up right at all. There we go. Under General, go down to Character Set, change it from Use Unicode Character Set to Use Multi Byte Character Set. Go down to the C/C++ section, precompiled headers, use No. Alright, now we can actually get to writing our code here. So let's go ahead and just build it. Everything is good to go. So we need to add a couple libraries in. First one's going to be windows.h, so we're going to do hashtag include windows.h. And just for testing purposes, in case we need it, we're going to include iostream. And we want to include our memman file. So we're going to do include memman.h, just like so. Now in memman we have two functions that we're primarily going to use, read memory and write memory. So as we have our get process and get module, so we want to go ahead and add a way to access it. And we can simply do that by doing, well, just looking at the class name. Class name is memman, so we're going to do memman, then we're going to give it a name. Let's just call it I don't know, mem class. So we're going to use pretty much access everything in the memman class through the name mem class. Alright, now we can go ahead and get the process and module. So if you look over here, get process takes in a constant char, which is pretty much, you can think of it like a string. So we're gonna, actually first let's make a structure. Now this is gonna have everything that we want to store in it. So we're gonna have our process, we're gonna have the handle, we're gonna have the module, we're gonna have our local player, and just kind of probably gonna add some more things as we go along. So we're gonna do struct, what would be a good name? I guess just values. And then our reference for it is going to be just simply val. So if you want to access the structure, well, everything inside the structure values, we just do val dot whatever we want to access. So let's go ahead and do local player. So we're going to do DWORD local player. And DWORD just process DWORD game module. Alright, so first thing we can do is go ahead and just get the process using get process. So we're going to take, again, it's going to be csgo.exe that we pass in. So we're going to do mem class, just like reference up here, dot get process. Then we need to pass in csgo.exe. Since it does return, we're going to want to do val dot process equals, so pretty much what the get process function returns is going to be stored in our process here. So this is going to return pretty much the ID. Now we want to get the module, so we're going to do val dot game module equals mem class dot get module. Now here's where we want to get our DLL, which since a new panorama update, instead of it being client.dll, it's client underscore panorama. I think I'm pronouncing that right. .dll. I got myself confused. So we're going to send in val.process and the client there. Alright, so just go ahead and test that we actually have the address of the module. We're going to see out hex val.game module, and we're going to go ahead and end the line. Now when we run it, we should have, alright, Shift F5, Control F5, duh. Alright, so it's not null. So we're go ahead and good, and we're ready to continue. Alright, so now that we got our access to the module, we want to get our local player. Now the way we can do that, actually the offset's written down. We can make a new structure. So struct again, game offsets. We're just going to call it offsets to act, well, if we want to access it, we just call it offsets. So we're going to have DWORD, actually I can just copy it. These will probably be different for you depending on which version of the game you're on. So I recommend just simply looking them up online, finding whichever ones are there for your current version. So we're going to go ahead and get access to it. So we're just going to do val.localPlayer equals, then we have memClass dot read memory. We're going to be passing in a DWORD. Then what it passes in is the address. So what it's going to be is the module itself plus the local player offset. So we're going to do val.gameModule plus offsets.localPlayer. So So now we can go ahead and check it, doing our cout again. Derp. Make sure it has a value, which it does. So we actually have our local player now. And just to add as a check, for instance, if you just started CSGO and you launch this program while you're at the main menu, local player, as far as I'm concerned, I don't think it would exist. It should return null. So we're going to go ahead and add a simple check. We're just going to run a loop. So while val dot local player equals null, then we're going to copy and paste this here. Then just so it doesn't just randomly run, we're going to just do an if statement. So if val dot local player equals null, we're going to do our loop. So now we can actually write what is going to pretty much be controlling our stuff. So the logic behind it is, if our player flag, pretty much our flag is going to kind of tell us what is going on. So for instance, if we're on the ground, the flag is going to have a certain byte. And if we're jumping in the air, it's going to be different, so on and so on, so on. And then our F jump, we pretty much just call this and write 6 to it, and it's going to force a jump. So if the user is holding spacebar and this flag is equal to whatever we want it to be, just assign this to 6 and you're jumping. So we can go ahead and run our loop. Just do while true. Now just so it's not running insanely fast, just do sleep 1. Now we're going to go ahead and do a byte comparison by getting our flag here. So in our values, we're just going to do byte flag. Come down here. Val dot flag equals mem class dot read mem byte, then the address. Now for the flags, it should be, let's see, flags. Yeah, flags are through the local player plus the flag offset. So it's going to be val dot local player plus, what is that called? Yeah, just offsets. Offsets dot flags. So now we need to figure out if this is equal to our player being on the ground, as well as if the user is holding spacebar. So we're going to use get a sync key state. So if get a sync key state vk space, and we want to do our flag comparison. So we want to do, let's see, val dot flag 1 0, and that is our comparison. And why do you keep adding extra parentheses? We're going to go ahead and cout can jump. Let's go ahead and try it. I'll get that where I can see it. Jump. Just holding the space bar, but when you're in the air, it does not appear. The message only appears when we're on the ground. So we can just simply write to it. So we're going to be writing to f jump from our offset structure. So come down here to our if statement. We're going to do mem class dot write memory, and we're going to be writing a DWORD. Then we're going to be passing in the address, and in case of this offset, we're going to read from the module and then add the force jump offset. So we're going to do val dot game module plus offsets dot force jump. Now this takes in two parameters, the second one being the value. We want to give it the value of 6. Then we understatement. So now when we run it, as long as I didn't completely screw this up, we should be bunny hopping, just like so. And that's about as simple as I can think of a way to explain it, but I'll just do a quick run through one more time. We make two structures, one which isn't necessary. You can do all these inside of main, but just keep everything nice and neat. We make two structures, one for our offsets and one to hold the values that we get. We include the memory class, which we use to get the process of CSGO, get the module of CSGO, and then read from memory and write to memory. So then when we actually get to writing what we want it to do, we use getProcess from the memman memory class. We pass in csgo.exe, the game, to it, and we assign it to process, which is in this structure here. Then we do the exact same thing, but with get module, and if you're using the panorama update, or UE, you would just pass client underscore panorama.dll into it, as well as the process, or the process ID. Now, we have to get the local player, obviously, so, which I do recommend putting this in the loop down here as well, but we go ahead and store our local player inside of the structure. We read from memory, and we pass, since the type is going to be a DWORD, because we're passing in the addresses. So we're going to be passing in the address we got from the game module here. Then we're going to be passing in from our offset structure the local player offset. So then we want to check and make sure our local player does not equal null, because if it equals null, you're just going to end up having issues when this tries to run and generally crash. So if the player equals null, we're going to run a loop that is going to continue to run while the player equals null, and if it ends up finding it after, let's say you start at the main menu, you start this program as well, then it's going to be running this loop. But when you go into the game, such as right now where you can actually move around and jump, it is going to read it, find it, and add the value to local player in the structure. So this loop is going to cancel out, and it's going to run our main loop. And in here we want to get our flag, which pretty much does literally everything the player is doing, jumping in and out of water, jumping up and down, in the air, on the ground, neutral, doing whatever. And the value for doing nothing and being on the ground is simply this here, and all we're doing here is just a simple byte comparison. So to get access to the value of our player at like what he's doing on the flag, we read from memory, and since it is a byte, we're going to pass in it as a byte. We're going to go off of our local player address and add the offset flags from our structure. Then we're going to go ahead and do a check. So if the player is holding space using getAsync key state, and if the value flag, we're doing a byte comparison to see if it equals that. Then we're going to write to memory, which we're doing just simply pretty much calling the force jump function, not necessarily calling the function because we're external at the moment, but we're just passing 6 to the value of this offset here. So we read from our memory class, we use the write memory function. It's of a type DWORD because we're passing in just offsets. Then we have the address being the game module plus offsets f jump or force jump, which is this value here, and then we give it a value. So we want to, whatever address this equals, we want to give it the value of 6, which is causing us to jump. And I think it's just 5 is not, or anything else, I don't know. Then just so this doesn't use up a crap ton of resources, we're just going to add a simple sleep 1 for, I don't know what that actually equals. If it'll say, yeah, just 1 millisecond. So it's really as simple as that. now we should, if you did everything correctly, you should have a working bunny hop. And if you follow the tutorial exactly and you're having issues, then odds are the offsets listed here have become outdated and you need to update them.
Thank you so much for watching. As always, if you love guided hacking, please like and subscribe and share our videos with your friends. If you want to donate, guidedhacking.com/donate. You can use PayPal, cryptocurrency, or become a patron on Patreon. That's patreon.com/guidedhacking. Thanks again for watching and stay tuned for more.